Hmm. Good evening, guys. I'm audible. Okay. So I will be taking the CodeChef Starters 2025 Division 2 contest. I have solved A to E solutions. So let's start with the first question. I hope I'm audible. Please write in the chat. Good evening. Okay, I guess I'm audible. So yeah, this is the first question. So there are n numbers written on a blackboard. So before that, let me start my whiteboard as well. So are you able to see my screen? Yeah. So let's start with the question. Okay, so it says that n numbers are written on a blackboard, and these n values are denoted by a1 to an from left to right, and you can modify the blackboard using the following three-step procedure as long as n is greater than or equal to 2. So basically, you can first add an to n minus 1, and then you can erase an from the blackboard and finally reduce n by 1. So what does this mean? Is that you can add the last value to the second last value and then erase the second last value from the blackboard. Uh, and until when you can do this? Till n is greater than or equals to 2. Obviously, because you should have at least two elements for this operation, right? And in simpler words, uh, what is told that add last value to second last value and then erase the last value from the blackboard. Okay. And you like even numbers, so you would like to know if it's possible to repeatedly perform this three-step procedure so that eventually only even numbers are written on the blackboard, right? So you just have to answer in yes or no. So if you uh, think about the question carefully, so what it says, first of all, okay. So for example, you have an array 2, 1, 1, right? You can do what? You can add this one to this one and delete this one. Add the last value to the second last value and erase it. So what will this array become? 2, 2. And you can see that you are left with all even numbers. So the answer to the test case will be yes, right? So like in this test case, the answer is yes. Uh, I hope you understood the question. Add the last value to the second last value and then erase the last value from the blackboard, right? So you add last to second last. So second last becomes 2 and you erase this one from the blackboard. So you are left with these two values. Both of them are even and that's what you want from the array, right? So the answer will be yes. Now the thing is, uh, you have to answer in yes or no whether you can convert it into an all even number array, right? So what will happen in that case? So like if you have AI, so A1, A2, A3, so on up to AN, right? if you have these values. So you say that you finally convert them into a dash 1, a dash 2, a dash 3, so on up to a dash small n. Obviously, because you will have lesser number of elements finally. Okay. So the thing is that if you are saying that this array has all even numbers, this array has all even numbers, uh, what can we interpret through this? First of all, what will you see that whenever you perform an operation, you change just the suffix. So after one operation, this array will look like a1, a2, a3, so on up to an minus 1 plus an, right? And after two operations, what will happen? After two operations, this array will become a1, a2, a3, so on up to an minus 2 plus an minus 1 plus an, right? So the thing is that the final array is nothing but a1, a2, a3, so on up to suffix some suffix sum, right? Some suffix sum. So what you need is that you will keep on adding elements in that last until all of these are already even, because these will not be altered. These will not be altered during the operations. All of the elements to the left are even, and this suffix sum is also even, right? Then only all the elements finally will be even. So what does this mean? This means that so suffix sum after sum I must be even, right? And also, and all elements a1 to ai minus 1 must be even, right? That's what we want. So uh, what you can observe from this is uh, so a1 plus a2 plus so on up to ai minus 1 plus ai plus ai plus 1, so on up to a n. This is what this is sum of all the elements of a, right? Now if you see carefully, if you look at this thing, we are saying that all these are even, all these must be even, right? All these must be even, and we are also saying that this sum must be even, this sum must be even, right? So so what will happen? This sum overall should also be even, right? This sum overall should also be even. Now you might be thinking that this overall sum should be even, right? Should be even because the all the elements are even here, or all the elements are even here, right? Now you might be thinking that uh that what will happen, that let us say a2 is 1 and this is also 1. Now these two elements are odd but their sum is even, right? But this doesn't matter, because in that case what will happen, in that case what will happen, in that case I will shift to here. Overall this whole sum will be even again, right? So the necessary condition and the sufficient condition is that sum of all elements of A should be even, right? This is the necessary and sufficient condition for this question. Because if the sum is even, then what will happen? Up till, let us say you take all the elements. Let us say you take all the elements. If the sum is even, you take all the elements and you are just left with a single element, one element only, one element only, right? So if you are left with only one element and that is even, only one element and that is even, your purpose is satisfied, right? So that is what I am saying. So you just have to keep on performing operations. Perform ops till only one element is left, right? Now that one element should be even, right? So the necessary and sufficient condition for the question is that sum of A is even. Do you understand, or do you have any doubt in this question? Have any doubt in this logic? Please write in the chat box. Okay, so you do not have any doubt in this question. So yeah, the implementation is obviously really simple right here. Implementation is just you have to calculate the sum of all elements. You calculate the sum of all elements of A, and if the sum is odd, you say that answer is no, and if the sum is even, you say that answer is yes. This is no. Okay, and sum of all elements of A. Okay, so yeah, the first question is done. Now let us start with the second question. I hope there's no doubt. If you have any, you can write in the chat box. I will open this stream side by side as well. Elements. Okay, okay, good. So yeah. So the next question is maximum score. So chef is participating in a tournament. He must face an opponents. If he wins against the ith opponent, he will receive AI coins. If he loses, he will receive BI coins. Now, obviously, if he wins, he will get more coins, right? So AI is greater than equals to BI, right? So like you play a competition and you win 5 coins on winning against the ith opponent, and let us say you win 3 coins on winning against on losing against him. Okay, obviously you would get more coins on winning. So that is why AI is greater than equals to BI. And Chef doesn't want too much attention to himself, so he wants to lose at least once. And under this constraint, what's the maximum number of total coins he can receive? So this is a basic brute force question. If you carefully look at it, uh, this question says this question says that you have to face n opponents, and if you win against the ith opponent, you will receive AI coins. Otherwise, you will receive BI coins. So what will happen? What will happen? So you have to play n matches, right? If you win ith, you get a plus of AI. If you lose, ith, you get a plus of bi. And obviously, okay. So, so what will happen? If you win ith, you will get a plus of ai, and if you lose ith, you will get a plus of bi, and uh, lose at least once one match. At least one match, right? You have to lose at least one match. So if you have to lose at least one match, what will happen? Uh, so let us say I am having A1, A2, A3, and B1, B2, B3, and I want to receive the maximum number of coins. So optimally, if I win all the three, I will get A1 plus A2 plus A3. But since I have to lose one competition, I have to lose at least one competition. So either I will lose this. If I lose this, what will happen? I will get plus B1 and minus A1. Or I will lose this. I will get plus B2 or minus A2, because this A2 was added to this sum. So now this has to be subtracted, right? So if I were to lose A3, I would get B3 coins, but lose A3 coins, right? I have these three options. Now the thing is, I have to lose once, and I want the maximum total number of coins. Maximum total number of coins. Right? Maximum total number of coins. So what will happen? So if I have to get the maximum total number of coins, then I will simply try what? I can simply try B1 plus A2 plus A3, or A1 plus B2 plus B3. Oh, sorry, A3. Because I have to lose at least once. And now you might be wondering, at least once is said in the question, so why not lose twice or thrice? So obviously losing more would would lead you to lesser points, right? Losing more is not good, not good, right? But you have to lose at least once, so you just have to lose just once, right? Because if you are losing more, you are obviously uh, not getting the most optimal number of coins, right? So what will we have to do? Initially, you have to keep a sum a1 plus a2 plus a3, so on up to an, assuming that I won all of the matches. Assuming that I won all of the matches, and then you run a loop. Then you run a loop I 0 to n or 1 to n, right? And I say, let us define answer equals to 0. Answer equals to max of answer comma sum minus ai plus bi. Now what happened? Basically, this is when I lose ith match, because if I lose ith match, I do not get the ai coins, so I have to remove the ai, and I get the bi coins, so I have to get the bi coins and remove the ai coins if I am losing the ith match. And I will brute force over all the matches, that uh, can I, if I lose this match, what will be my answer? So this will be the final answer, will be the maximum of all the cases, and finally I will simply print the answer, right? So these two questions were completely brute force questions, right? Let's open the code. Okay, so yeah, this is what I have done. So just to take the inputs, n and an array A and an array B, you calculate the sum of all the elements of A. Now, assuming what did I tell you? You lose just one match, right? And assuming you lost just the ith match. And finally, the optimal answer. So yeah, this is more or less the second question. So the first two questions were nothing but brute force approaches only. I don't think any of you might have failed to solve these two questions. So let's move on to the third question. The third question might be a bit tricky for some of you, but let's read this first of all. So you are given an array A of length n. This array can be modified by performing the following operation. So you choose an index I, and then for each index j, if j is less than I, you add ai to aj, and if j is greater than or equals to I, you do subtract ai from aj. And then know that every element of A must be modified. So yeah, from J1 to N, every element is modified, right? So it is. So an example is given. I will explain this. The question says you would like to make all the elements of A equal by performing the given operation several times. So you just want to make all the elements of A equal, and you can perform the operation any number of times. Now it just asks yes or no. Is it possible to make all the elements equal, or is it impossible to make all the elements equal? Okay, so let's start with this question. First of all, let me come up with this example: 2 4 1 2 4 minus 1 3 2 4 minus 1 3. Now think about it. I choose this element, and I choose this I basically, and I choose to apply an operation. Now what will happen? It says for j less than I, add ai to aj. So for j less than I, add ai to aj. Add ai to aj. So simply 2 minus 1, 4 minus 1. And for j greater than or equals to I, subtract ai from aj. So what will happen? Minus 1, minus 1, and 3 minus minus 1. Right? So this array transforms into what? This array transforms into 1, 3, 0, and 4. 1, 3, 0, and 4. Right? Uh, Now the observations that you can draw from this thing is that if you select ith index, it becomes 0. It becomes 0, right? It becomes what? It becomes 0. Now the thing is, okay, if you select ith index, it becomes 0. And the thing is that if ai is positive, if ai is positive, then what will happen? So you will add ai to before. You will add ai to all the j less than I. So ith index will become 0. Before before this, the values will increase. All the values will increase, right? And after this, all the values will decrease because they are here. A positive number is subtracted, and here a positive number is added, right? So this is the case if ai is positive. Okay, so what if AI is negative? If AI is negative, still the ith index will become 0, but the numbers after will subtracted from some, so I will subtract some negative thing. So the numbers after this will get what? They will increase, and the numbers before this will decrease. Right? Okay. You don't need to add some since it's a constant value. I didn't get you. Okay, let's be quick. Let's be quick. So the thing is, this will happen if you select such an AI, right? Okay. Now, um, imagine I have an array 1, 1, -1, -1. So what will happen if I let us say choose this -1, the array becomes 0, 0, 0, and 0. Right? The array becomes 0, 0, 0, and 0. Um, or let us say I had 1 -1. Okay, not 1 -1. I had -1, -1, 1, 1. And I choose this 1 once again. So what will happen? Again 0, 0, 0, 0. Right. Now the thing is, let us say I have this array 1, 2, 4, 1, 2, 4. What will happen if I choose any of the indexes? Let us say I choose this. What will happen? 3, 0, and 2. 3, 0, and 2, right? Because -2, -2, and +2. Now this is the case. Now what happened is that this element right here becomes 0, but these two elements are not 0, right? And if you carefully think about this, if one element has become 0 and other elements are not 0, then what will happen? Then what will happen? The elements can never be same, right? The elements can never be the same now, because let us say you select after this 3. Now what will happen? What will happen? 0, -3, and -1. Little -3 and -1. Because now this will become 0 and this will become non-zero. So what do I mean by this? What do I mean by this? You get 1 0 in the array and any other non-zero element. The answer is no. The answer is no. Why is it so? Let us say you have 0 and just a single other element AI. What will happen? If you choose 0, so there are two options. If you choose the 0 or if you choose the AI. If you choose 0 from here, what will happen? The array will remain the same. If you choose AI from here, the array will become AI 0, right? But the elements will never be same. The elements will never be same. So the thing is, and you also know that whenever I apply an operation, you also know that whenever I apply an operation at ith index, y is equals to 0. Now, if aj, if there exists aj, if that aj is not equals to 0 after operation, then the answer is no. Okay. Green, not blue. Okay. If I didn't get anything, I will just tell you in short. What did I just tell you? So the main thing is that after one operation, AI will become zero, and you get zero and a non-zero element together, you get a zero and a non-zero element together, then the answer is no, because 0 comma AI could result in 0 comma AI or AI comma 0 if, if you select 0 or if you select AI, right? If you choose this as I, then you get this array. If you choose this as I, you get this array, but you can never make them equal. You can never make them equal. So the thing is, after one operation, you will get at least one zero in the array, and if all the elements are, if there is any non-zero element in the array, the answer will be no. So what do we want? What do we want? We want to make all elements equal. If we want to make all the elements equal, then what do we have to do? Then after one operation, after one operation, what should happen? All should be 0, 0, 0, 0, 0, so on. Right? Because one, at least one will become 0, and if there is any non-zero number with a 0, you cannot you cannot make all the numbers equal. So you just have to get what? You just have to get all the zeros, right? So how many cases of such cases are possible? So for example, let us say you have an array 5, 5, 5, 5. You have an array 1, 1, minus 1, minus 1, or you have an array minus 1, minus 1, 1, 1. Only the cases of these three types are possible, right? Either all the elements must be equal, or in such a case you can apply an operation at this index. In such a case, you can apply an operation on this index. These are the three possible ways. This is just to enumerate the ways. But if you cannot list all the cases specifically, we have another thing as well. We have another thing as well. So let us say I have an array A1, A2, A3, so on up to AN, so on up to AN. Let us say I have this array, and I say that after one operation, after one operation, all should become zero after one operation. So why not try and apply this operation? Why not try and apply this operation at every index, right? At every index. But then that could take a time complexity of O of n square, which is, yes, which is obviously allowed in this question, right? So so you go for index 0 to n. What will you say? That, let us say this is the chosen I. This is the chosen I. If this is the chosen I, what will you do? So let's simply write this in the code, since I have uh, coded in this question in some other way. So why not write this in the code itself so that you get an even better understanding. First of all, let us take the test cases. right? And in 10, right? So what did I say? The first observation is all elements must be zero after the operation. Otherwise, answer is no. Okay. So let us try to apply the operation on all the indices. Here's an index for the operation is I. And why for the operation? Because for the only operation actually. Because there will be only one operation if the answer has to exist. There will be only one operation if the answer has to exist. And after that one operation, the elements must turn into all all the elements must turn into all the elements must turn into zero, right? So if I apply operation on J, what will happen? Vector of integers B equals to A. So we will make a copy of A so that the original A is not corrupted. Now what will I do? I will say J equals to 0 and J less than I, J plus plus. What will happen? So for the indexes less than I, what do I have to do? I have to add AI. I have to add AI, right? So uh, B of J plus equals to A of I, and then what? J equals to I and J less than N, right? So for this is for indices less than I, and this is for indices greater than equals to I, right? So this will happen, and we will get B of J, right? Now what? Now what? So for int we will keep a boolean answer equals to false, equals to true. Answer equals to true means I will assume all are zero. If B of J is not equal to zero now, this means that the answer has to be false. So, right? Answer has to be false. Now, if the answer is not false, you can do what? This means that all the elements will be zero. Else you can do what? Else you can do continue. You can try another I. You can try some another index, right? Some other index. Now, if you this is actually not needed. The thing is, what we should get all the elements as zero. So right. So we will assume that okay. So if answer, you can see out yes, but printed equals to false. And if you are doing see out yes, then you can say printed equals to true and break, right? Now, if you have not printed anything, then you must print no, right? Yeah. Ah, so printed means that the answer has been printed as yes, and then you apply a single operation choosing the index I. So after applying the operation, you get the array B. If any element of the array B is non-zero, then that means that this is not a valid index. So the answer is false. If the answer is false, you have no option but to continue. If the answer is true, then that means all the elements, all zeros after applying operation on index I, on index I, right? On index I. So this is the code. Let's run this. Yes, no, yes. Let's submit this as well. That's answer. So yeah, this was the main concept of the question. That first of all, you must realize that only one operation is needed. Why one operation is needed? Because after one operation, the main concept is what? The main concept is what? That only one operation is needed. Only one operation needed. This is the main concept. And why is only one operation needed? Why is only one operation needed? Only one operation is needed because after one operation, I is zero, and if any element is non-zero now, and it means this is invalid. Right? So you have to find such an operation which results in all the zeros, and this is what we have done in the code that I just showed, right? Yeah. So yeah, this code works. I hope you understood this question. You can write in the comment box. Okay, so since the result in array should be zero, there must be consecutive negative integer followed by consecutive positive integer or vice versa with the same magnitude. Yes. You can solve this in O of n. That is what I told you right here. But the thing is, sometimes you some people might not be able to enumerate all these cases, right? So this was what I submitted as well. That either all the elements can be equal, or you can have some positive followed by some negative, or you can have some negative followed by some positive. Only these three cases are actually possible. So you can solve this question in O of n time complexity as well if you are able to recognize all these three cases. So yeah, shout out to Arun for this. Okay, so let's move on to the next question quickly. So this is the next question. Near yet far. So you are given an array A of length n and an integer k, which is between 2 and n. Now, a sequence of indices is said to be valid if, yeah, these are in increasing order, no consecutive indices are chosen, and now this is something that you have to understand carefully. So I1 is less than equals to k, IR is greater than equals to n minus k plus 1, and between any two i's, the distance should be less than equals to k. In simple words, among any contiguous segment of length k, at least one index has to be chosen. At least one index has to be chosen. And in particular, choosing a single index k gives a valid sequence. Give, in particular, choosing a single index gives a valid sequence if the chosen index is less than equals to k and greater than equals to n minus k plus 1, which is very obvious according to the last condition, right? Now, if score of the valid sequence is defined to be max over all the indices minus min over all the indices. And now you're given the array A, you're given the parameter K. Your task is to compute the maximum possible score of a valid sequence of indices. So let me clarify this question first of all, because it's really important to clarify this. So for example, let us let us use this test case. Okay. So this test case is what? Y equals to N equals to 4, K equals to 3, and A equals to 8143. Right? 8143. Now what will happen if A equals to 8143? then then what? You have to maximize the maximum minus minimum. 4 equals to max over AI1, AI2, so on, minus min over AI1, AI2, so on. Right? Now we have to choose two indices, two indices or three indices. If you carefully observe, we just need to think about max and min, and we do not need to think about any other index, right? So if you think carefully for this test case, so optimally you can say that I can choose 8 minus 1, but can they be actually chosen together? Because you have to maximize the score, right? So you will say 8 minus 1 equals to 7, so why not choose 7? Is it actually possible to choose 8 and 1 at the same time? That's the question. So it is not possible because of the second condition that is told. So no two chosen indices are adjacent. Let me write all these conditions for you so that it becomes a bit easy. I1 is less than I2 is less than I3, so on is less than IR, and then what? IX minus IX plus 1. So IX plus 1 minus IX is not equals to 1. This means that consecutive indexes cannot be chosen. So these two are consecutive indexes. These cannot be chosen. And also ix plus 1 minus ix is what is less than or equals to k. So like, and also I1 is less than equals to k, and IR is greater than equals to n minus k plus. So these conditions might sound a bit intimidating to you, but trust me, you just have to focus on this thing. You just have to focus on two indices, and you have to just find, can I actually use can I actually use which two indices? You do not have to focus on other other parts of this of the sequence of indices. Okay. So the main thing is that you just have to focus on max and min. So like what if I say that the max is this 8? Now the thing is, I am left with these three elements for the score. I know that I cannot have one. I cannot have one. I cannot have one as the element in the sequence, right? Because it is adjacent to it. But I can obviously have 4 and 3 because they are lying in the limit of less than equals to 3, right? So limit of less than equals to 3. Distance should be less than equals to 3 as well because of this condition on k. Right. Like if I had 8, 1, 4, 3, and 2 with k equals to 3 again, the thing is that 8 cannot select 1 because it is adjacent. 8 can select 4 because its distance is 2. Can select 3 because its distance is 3. Cannot select 2 because its distance is 4, which is greater than equals to k. So this will be invalid. So you can choose either 4 or 3, right? Either 4 or 3. Yeah. Yeah. And the thing that I am about to tell you is that you do not need to just select the next possible element, right? So what will you do? Yeah. Now what I'm asking you is that can 8 have 2 anywhere in the sequence? The thing is that. So listen to this thing carefully. Let us say that I1 is at 8 and I2 is at 4 and I3 is at 2. I3 is at 2. Is this valid? Is this valid? First of all, tell me. Is this valid? Yes, this is valid because none of them are adjacent and they are lying within the bounds of K as well. So this is a valid thing. But as you can see, 8 directly jumps to 2. 8 directly jumps to 2. Now you might be wondering, in this case, I have to worry about the elements, not just two elements, but three elements, right? So I have to worry about not just two, but three elements. But that's not the case because what I'm about to tell you is something logical. So the thing is that if I have some ij and I want to see that which elements can I not select. So first of all, let us come to a case of k equals to 2. Okay, a case of k equals to 2, what will happen? So let us say you have this array 8, 1, 4, 3, 2. Now 8 can select, not select this, 8 can select this and not this. 8 can, right? So this is a constraint that only 4 can be selected. Only 4 can be selected. And now you come to 4. 4 knows that this cannot be selected. Only this can be selected. So in case of k equals to 2, you can clearly observe that you can take a sequence a1, a3, a5, so on, or you can take a sequence a2, a4, a6, so on. in case of k equals to 2. In case of k equals to 2, only these two sequences are possible, right? Is this clearly understood? If you have any problem in understanding this, please tell me. For the case of k equals to 2, if you have any problem, you can tell me. In the case of k equals to 2. Okay. Now there's no problem in case of k equals to 2. So for k equals to 2, these are the possible sequences, right? These are the possible sequences. So you kind of you can brute force them. So you can find max minus min here, max minus min here, because only these two sequences can be taken, and then you take max of these two things, right? You can take max of, let us say this is score 1 and this is score 2. Both the scores are achievable. So max of score 1 comma score 2 is the answer in case of k equals to 2. So this is a case that we handled very carefully, because in case of k equals to 2, only the next element allowed is at the index I plus 2, right? So this is something that we observed about k equals to 2. Now what if k is not equals to 2? Now the k is basically greater than 2, because according to the constraints k, so the k cannot be 1, k can be 2 or greater than equals to 2. So right, greater than 2. So now let us talk about the case when k is what, greater than 2. Now let us come back to the example 81432. So let us say I choose 8 to be the max element. I fix that this is the max element to be chosen. This is the max element to be chosen. Right? This is the max element to be chosen. Now what can be the min element? So the next element could be either 4 or 3, considering this as k equals to 3, right? Either 4 or 3. Now the message that I want to convey you is that if I have chosen index I can choose I plus 2, right? I can choose I plus 2 for sure, for k equals to 3. I can choose I plus 3 as well for k equals to 3, right? Now I am asking you what? After I choose I plus 2, I can also choose I plus 4, right? After I choose I plus 2, I can also choose I plus 4. Is that clear? After I plus 2, I can choose I plus 4. So what I'm trying to tell you is that after I can have I plus 2 in the array, I can have I plus 3 in the array, I can also have I plus 4 in the array. I can have any of these in the array, right? So what is the hint? If I say that this is the maximum element, this is the maximum element, and I can choose the minimum of these three as the minimum element, minimum of these three to be the minimum element, right? Because understand, although I plus 4 cannot be the next one, right? Since k equals to 3, I plus 4 can't be the next ij, but it can be in the sequence. Right? Let me ask about I plus 5. Can I plus 5 be in the sequence? I plus 5 be in the sequence? Yes, I plus 5 be in the can be in the sequence I plus 2, and then I plus 5. You can choose I plus 5 in the sequence. Can I plus 6 be in the sequence? Yes, I plus 6 can also be in the sequence. You can choose I plus 3, I plus 6. So you can choose any element other than AI plus 1 to be in sequence, right? To be in sequence. So if I'm choosing a middle element, let us say in this case I have the array 8, 1, 4, 3, 2, I choose, I say that 4 is a max. 4 is a max or a min. Now I cannot choose 3 because it is adjacent. I cannot choose 1 because it is adjacent. But all the remaining elements could be the corresponding min or max for this, right? So this might be difficult to interpret. Uh, I would love if there is any confusion. I would love to hear if there is any confusion from your side. Okay, I would love to hear confusion. So kindly tell me in the chat box if there is a confusion. I will wait for you all. Okay. So I can see no confusion. The thing that I'm conveying is that first of all, in k equals to 2, you can do, you are having only two options, which have been enumerated. Now for k greater than 2, you can have max at ai and min at any aj such that aj such that j minus I is not equal to 1. So basically they are not adjacent, right? You can have max at ai and min at any aj. Similarly, similarly, you can have min at ai and max at any aj such that I and j are not adjacent, right? This is what I have to do in the implementation now. In the implementation. Now, how am I supposed to implement this? Let's carefully look at my code. Carefully look at my code. So the first thing is that if k is equals to 2, so this is the test case. If k equals to 2, what I have to do is, what will have to do? What is to be done? A1, A3, A2, A3, A4, A5, A6, right? So I have to get the minimum of A1, A3, A5. So this is stored in minimum 1. And I have to get the minimum of A2, A4, A6. This will be minimum 2 and the maximum 1 and the maximum 2. So, this is nothing but score 1 comma score 2 comma x. Did you get this? If k equals to 2, so you are left with only two options, A1, A3, A5 or A2, A4, A6. It is a constraint. You evaluate both the options and get the final answer. For k equals to 2, it should be very clear to all of you. Now for k greater than 2, everything except a minus 1, ai minus 1 and ai plus 1 is available. So I go to every index. I have a multiset. Now for such kind of questions uh, of sliding window type, you can always use a multiset data structure because you can erase and insert elements at any given time. So what do? You erase the previous and the next adjacent element. Previous and the next adjacent element. Obviously, this edge cases have to be handled because like for 8, 1, 4, 3, 2. So like for 4, I have to remove both 3 and 1. Right? For 4, I have to remove both 3 and 1. Yeah. For 4, I have to remove both 3 and 1. But for 8, what do I have to do? I have to remove only 1 because there is there is no previous element, right? So I have to write this edge case that if I greater than 0, if I less than n minus 1. So I erase adjacent elements on the multiset, and now what will happen? What will happen? So, okay, so assuming that AI is max, This thing is assuming that AI is min. So basically, all the elements that are possible, you find the minimum of all those, and that can be AI minus minimum can be the answer, assuming that AI is the maximum on the sequence. And you find max of all the elements that I can take, and maximum of mx minus AI could also be the answer if I assume that AI is minimum on the sequence, right? So these two are the proper ways to do this. Have mx have max at AI and min at any AJ. Have min at AI and max at any AJ. So this can be done in this way using a multi-set data structure. So if you are not clear with the implementation or the logic, you can just quickly write in the chat box. If you have any problem in the okay, so someone is saying move to the coding part. Obviously, I've explained the coding part now. If you have any problem with the coding part, you can tell me quickly, right? So I will move on to the next question as well. Don't worry. If you have any problem in this one, please tell me. Okay. Okay. I hope there is no problem now. Now, let's move on to the last question for the day, prime prefixes. So this is not a simple question. For an array B of length m, you have to define the prefix sum s of I is equal to. Mhm. I have defined, you have been given the definition of prefix sum s of I, and you have been said that f of p is the number of indices I such that s of I is a prime number. And s of I is what? S of I is basically the prefix sum up to the index I. Okay. Now you're given an array A of length n, which consists of only 1 and 2. Um, Let m denote the maximum value of f of b among all the arrays b that can be obtained by reordering the elements of A. So basically, if you reorder the elements of A in any way, uh, you will get some array B for which the value of f of b will be maximum, right? And now we will say that m is that maximum value. Okay. Now you are allowed to perform the following operation multiple times on A. This operation is that you can swap the adjacent elements. Now you have to compute the minimum number of adjacent swaps required to transform A into some array B, right? Hmm. Mm. Okay. So you have to find the minimum number of swaps to transform A into B, right? And the thing is that, so let us take an example. So for example, this 1122. For example, I have the array 1, comma 1, comma 2, comma 2. Ah. Now I want such a reordering. I want to confirm such a reordering, so that I have the maximum value of f of b. Now what is f of b? First of all, let us try to calculate f of b here. So prefix sum up to here is 1, up to here is 2, up to here is 4, up to here is 6. So I have only one prime. So f of b is equals to 1, right? Now I have to find a reordering. Let us say I make a reordering of this 2, 1, 2, 1. Okay, I make such a reordering. Now I have to calculate prefix sums. So prefix sum up to here 2, 3, 5, 6. Right? 2, 3, 5, 6. Now what will happen? So uh, 2 is a prime, 3 is a prime, 5 is a prime. So f of b is what? 3. So in this case, this is also the value of m. Now I have to find the number of steps to convert this into this. I have to find the number of steps, right? So what will be the number of steps? If you carefully observe, 1122 to be transformed to 2121, right? So what can I do? I can do 1212 after swapping these two, and then I can swap these two. This will become 2112, and then I can swap these two. This will become 2121. So how many swaps should it require? One swap, two swap, three swap, right? Right. So now what? Now the thing is that how do you count the number of how do you count the number of steps? So the answer will be what? If you find the number of changes in the positions of just ones, you can calculate the answer, right? So like this one is displaced by how much position? One position. So obviously it will have undergone one operation, right? And this one has been displaced by two positions. So obviously it will have undergone two swaps, right? So the answer is 1 plus 2 equals to 3, right? So in this way you can find the number of swaps. Answer or the number of swaps to reach from A to B. If we understand the number of swaps to reach, then we will discuss uh, how to make the optimal array B as well, right? So xi minus yi, I equals to 1 to k. So basically, what is xi? Old position of 1. And what is yi? This is new position of 1, right? Now what will happen? Now what will happen? Mm, so we want to find the optimal array B now. Uh, so let us say that I had this array 1, 1, 2, 2. Now this question requires the use of DP as well. So let us say I define DP of I comma j uh, such that I have I ones, I ones and two j's still here, and they are placed optimally, right? This is DP of I comma j. Now what is the meaning of placing optimally? First of all, let us talk about that. So let us say I have this array 2, 1, 1, 2. So as you can see, what is the sum? What is the sum of this array? Sum of this array. The sum of this array is what? 2 plus 1, 3, 4, 6. So if I have the sum as 6, why not try to make all the primes up to 6? 2, 3, and 5. Why not try to make all the primes up to 6? So we can see that 2 is already available, 3 is already available. Swap these two, and you also get 5, right? So 2 is available, 3 is available, 5 is available. Correct? Now what will happen? So we need all the primes. We need all the primes. Primes less than equal to sum. Is it always possible to make all the primes? Uh, Now the thing is, no, it isn't. No, it is not. When is it? When is it not possible? When you have no one in the array, right? So if you have no one in the array, then what will happen? If you have no one in the array, then what will happen? 2, 1, 1, 2. So if you have no one in the array, let us say 2, 2, 2, 2, then how will you actually make an odd number? You cannot make an odd number, right? You can't get odd numbers. Then it is problematic. Then it is problematic. But if you even have a single one, if you even have a single one, you can obtain all primes. Clear? So, first of all, we will handle these two types of cases. If all the elements are ones or if all the elements are two. Obviously, you cannot make a reordering of this, of these two cases, right? You cannot make the reordering of these two cases. So, anyway, the optimal reordering will also be this array itself. So there are zero swaps required. There are zero swaps required. So if you are having all ones or all twos, the answer will be zero. So this edge case is handled. Now you know. Now you know you have ones and twos both. Now what will happen? Means that means that all ones, all primes less than equal to sum have to be made. Have to be made. Now what will you say? If all the primes less than equal to sum have to be made, now I am saying that dp of I comma j I have defined I ones and I ones and j twos up to I plus j index, right? What is the cost? What is the cost? So this is the minimum cost of getting I ones and j twos up to I plus j with minimum swaps and having all primes less than equals to I plus 2j. Why I plus 2j? Because I plus 2j is sum up to this index, right? So I plus 2j is sum up to this index because there are I1s and J2s. So the sum will be I plus 2j, and I want to obtain all the primes up to this position, right? So like I have 1, 1, 2, 2, 1, right? So there are three ones and two twos. So I need all the primes up to 3 plus 4, 7. All the primes up to 7 in this, right? So how will you handle this? So if you want to place, if you want to place a 1 at the I plus j position, if you want to place a 1 at the I plus j position, then I plus 2j is the sum up to here, right? I plus 2j is the sum up to here. You can place one anytime, right? You can place one anytime because then no prime will be skipped, right? So let us say 6 was sum up to here. After adding 1, 7 will be the sum. तो कोई नंबर स्किप तो नहीं हुआ 6 और 7 के बीच में नहीं स्किप हुआ सो यू आर स्किपिंग नो प्राइम राइट सो यू कैन प्लेस a 1 at any position, 1 at any position. If you want to place a 2 at I plus j position, then I plus 2j minus 1 was skipped, right? Because इसका मतलब क्या है कि इससे पिछले तक का सम क्या है I plus j minus 1 into 2 which is I plus 2j minus 2, and after adding a 2 the sum will be I plus 2j. But what is skipped? What is skipped? What is skipped? I plus 2j minus 1 is skipped, right? If I plus 2j minus 1 is skipped, when would the problem arise? If it was a prime. If it was a prime, there will be a problem because you cannot skip a prime. You cannot skip a prime, right? You cannot skip a prime. So this is the DP right here. So DP of ij could be what? So if you place a 2, if you place a 2, then it will be simply I comma j minus 1 because placing a 2 does not require any cost, as we see here, as I wrote this formula here, if you remember this formula carefully. So we are uh, incurring a cost only on placing a 1, only on placing a 1, right? So we are incurring a cost only on placing a 1. So if I place a 2, there is no cost incurred, but when can I place a 2? Only if I plus 2j minus 1 is not a prime, is not a prime, because if it is a prime we cannot do this thing. And i can I can do this anytime. Yes, dp of I minus 1 comma j plus, because now I will incur a cost obviously, xi minus I plus j. Xi is the old index of ith one and I plus j is the new index of ith one, correct? So this is the dp that I have to make. And I hope you guys understood this DP. It's not that simple and it's not quite hard at the same time. But let me show you the uh, code for this quickly because the code forces PCD also has to start after this. First of all, I store all the. First of all, I have this prime. So this will tell you if a number is prime or not. You have to keep a track of this as well because obviously you need to check if a number is prime or not. So I store all the indices of ones. This is basically the X array, old position of 1, right? Now, if there is no one, simply print 0. If there is no one, simply print 0 because no reordering is possible. Now, what happens? Now I'm making the DP array. How will I make that? So basically, see this. You can first of all 1 in 9 से initialize कर दो, and then you can take it minimum of dpij comma I minus 1 j plus absolute of from minus 2. From minus 2 का मतलब क्या है? The cost incurred after placing the 1 at this position. And what is the cost? What is the cost that I just told you? Xi minus mod xi minus I plus j, right? Xi minus I plus j. So from is nothing but ones of I minus 1, and 2 is nothing but I plus j minus 1. And this is the cost after placing a 1 at this position, right? And why dp of I minus 1j? dp of I minus 1j means कि I minus 1s और j2s, I minus 1 ones और j2s को प्लेस करने में कितना लगेगा, राइट? I minus 1 ones और j2s को प्लेस करने में कितना कॉस्ट लगेगा, राइट? Now, if I plus 2j minus 1 is not a prime, then you can also place a 2. You can also place a 2 at this position. So try placing the 2 as well. So we will take minimum of dpij, comma dpij minus 1, because I ones and j minus 1 twos before this position, right? And finally you get the dp array, and in the end you print dp of p comma q, where p is the total number of ones and q is the total number of twos in the array. This is all from my side. I hope you understood the question. If you have any doubt, you can mention in the comment section. It's a detailed explanation that I have given you. Thank you for listening to me, and hope you will attend the code courses post contest discussion now. Thank you.
Hello everyone. Why aren't we live?